Welcome back, students. So this is another problem in which we have to find out the equivalent resistance seen by the source and finding the power developed by the source. So in here we have to find the equivalent resistance first. So in order to find the equivalent resistance, we have to start from this end. So here we can see that this 18 ohm and this 12 ohm, these are in series with each other. So writing them in so adding them initially, because the same current is flowing through these two, and and by adding them we will get another resistance. Okay, let me remove it. Okay, so here we will have this one. This is now 18 plus 12, this which is 30 ohm. Okay, and at these two ends we have, let us say that this is its end. So here we have another resistor connected which is of 60 ohm, and at this end we have another resistor which is of 30 ohm, which is this one, and here we have this 75 ohm. So let me solve it till this end, and we will solve the other resistors after solving this circuit, this one and this one. Okay, so now here we can see that this 30 and 60, these two are in parallel with each other. So solving these two parallel resistors, this is now 20, this is 60. Okay, solving these two parallel resistors, we will have to find out the value which will be equal to 30 multiplied by 60 divided by 30 plus 60. Okay, so this will be equal to 1800 divided by 90, so it is equal to 20 ohm. So you can ask me from where did I get this formula. So this formula is obtained by this formula, in which when two resistors are in parallel, their equivalent resistance can be found out by this formula, finding the LCM and then solving it, taking the reciprocal of this one. We will get something like R1 R2 divided by R1 plus R2, which is equal to the R equivalent. So this is the formula which I am using here and again and again in order to find the equivalent resistance of a parallel resistor. So as we have find out its value, so it will be now like this one. This is now 20 ohm. With 20 ohm we have here 30 ohm. Okay, this is now 75 ohm. So these two are again our resistors which are in parallel with each other. So let us find the equivalent resistance of these two as well. So their equivalent resistance will also be equal to 20 multiplied by 60 divided by 20 plus 60. So this is equal to the this is equal to almost equal to the this is 1200 divided by 80. So this is equal to, let me use the calculator here, 1200 divided by 80. So this is equal to the 15 ohm. Okay, so this is now, this value is now 15 ohm. So this, let me write 15 here. Okay, and similarly we have another resistor which is connected here, another resistor which is here, another here, and a source here. Okay, this is now 40, this is the 50 ohm, this is the 20 ohm. So, and again the same scenario is happening here, because now these two resistors are again in series with each other. So by solving them by adding the value of 20 and 30, we will get another equivalent resistance, which will be here. So this is 50, 20 plus 30 is 50, which are in parallel with this 75 ohm. So this is now the case in which 50 and 75 are in parallel with each other. So in order to find the equivalent of let me go down. Okay, so now this is the case. So now here 75 is in parallel with 50. So this is now 75 plus 50. So this will be equal to the 75 into 50 divided by 125. So this is I think equal to the 30 ohm. Yes, this is equal to the 30 ohm. So now this resistor, now this one is equivalent to the 30 ohm, with which here we can see that, with which we have seen another resistor, this one, which is here, another here, this is again 20, here we had 15 and 40 here. Okay, and source here. So this was the case. Again we can see that okay, this was 50. Again we can see that these two are again in series. So solving them for series, we will have 50 here. The two ends of it are connected with the two ends of these sources. So now we can equally convert it, and its combination will be like this one. So this is now, so this is now this one, this is this resistor, and similarly this is the 15 and 15 ohm, this is the 40 ohm, and a source. Now you can see that we have been 80 milliamps source. So now you can see that we have basically made it quite easy to solve. So now here again 50 and 50 are again in parallel. So finding the parallel combination, the two same resistors, so their equivalent will be equal to the equivalent will be equal to the combination, the same to the will be equal to the half of the any of it. So this is 25. Now this is this one. So let me see, did I make any mistake? 75 this 30, no, sorry, I thought I have missed this one. Now I have considered it here. So let me solve it. 15, this is 40, this is now this circuit. Okay, now here we can again see that these two resistors are basically in series with each other. So going now towards this direction, these adding them together, we will get 15 plus 25, which is equal to 40. 40 is in parallel with this 40 ohm, and again this source, which is of 80 milliamps. Okay, So now this 40 are basically in parallel with each other, and this two same resistor, their parallel equivalent will be the half of any of the one resistor. So okay, so half of the 40 can be written here, and that would be equal to the 20 ohm. With the 20 ohm we have our source which is of 80 milliamps. So this 20 ohm is basically our equivalent resistance, which we had to find out, or this resistance which the source is looking at, or this resistance which is found by the source. So this was our question, in which we have to find the equivalent resistance of this circuit. After finding it, we have to find out the power provided by the source. So the power provided by the source can be found out by T is equal to I square R. We know the value of I, which is 80 into 10 raised to power minus 3 whole square multiplied by the R, which is 20 ohm. So this is the value of the power which is provided or generated by the source. So in this question we have found out how to find the resistance of a very complex circuit. So we have solved this circuit by step by using the conventional methods or conventional concepts of series and parallel circuits. So this was our question. In here we can find or see many important concepts lying in this circuit. So thank you so much, and I will see you in next